Hey everybody, Mrs. Bixler here, and we are still cruising along with our work on trigonometry. And you probably saw these two problems in your homework, and you were like, what? Do you like my what written so you can also read it and hear me? So the reason why you would have that reaction with these two triangles is, remember, we feel super comfortable solving a triangle, like finding missing sides, missing angles, if it's a right triangle. But for both of these triangles, do you notice how there is no right angle? So we don't know whether or not these are right triangles. They might be, but we don't know. So we need to have a way to attack these kinds of triangles too, because there are going to be unknowns in real life, where we need to find angles or side lengths, sort of like what we talked about with the applications of trig. But it's not going to be a perfect right triangle. So we have tools to do that, and I'm going to teach you one of them right now. So the first one is called the law of sines. And the law of sines is really cool. It's really straightforward. And we'll talk about the proof later in class. But the law of sines essentially says the ratio between the sine of an angle and its side, whoop, and its side opposite to it is the same as the ratio of the sine of the other angle and its side opposite to it, which is also the same as the sine of the third angle over the side opposite to it. So it's always just going to be that ratio, the angle, the sine of an angle over the opposite side. And notice that I used lowercase letters for the sides and uppercase letters for the angles. That's really important. And when we work to solve a triangle, you'll see why specifying whether it's degrees or units and whether it's a capital A or a lowercase a matters. All right. So right now you should feel really good about this concept. So now let's put it to work. So the law of sines is going to happen in two situations. When we have an angle side situation, so see how we've got two angles here, and then the non-included side, and then this side angle situation. So I've got an angle and two sides. And remember, we always do side angle because we're classy. But we have two sides and then the non-included angle. All right, so these are the two situations where the law of sines comes into play. And we're going to tackle the angle side situation first. So no matter what, when we are given two angles, and we know this from our work with congruent triangles, if we're given two angles and the non-included side, we know that there's only one way for us to create a triangle. So if I match up these two angles and then this side, something like that, you see how there's literally only one way I could extend this boop, bop, boop, bop, boop, bop, boop, bop, boop, bop, boop, and create one triangle. So I know if ever I'm given two angles and a non-included side, I know that I'm going to have one triangle here. And what's important with law of sines that you're able to create a ratio. So do you see here right off the bat, I could have the sine of 55 degrees over 13, that opposite side. So once I see that I have that ratio, I have an angle and an opposite side, I can create that ratio. That's when we know we can use the law of sines. And then let's say I'm solving for side B here. I'm just going to call it side B. I would then say that this is equal to the sine of 61 over B. And then you would cross multiply and solve. So let's put this into action. So here I am, case one, angle side situation. I know you see a lot of blue boxes, do not worry. I want you right now to look at this, and I want you to set up that first ratio. So this should look really familiar to you. And I want you to set up that first ratio in order to solve for side B. Pause the video, go. All right, we're back. So hopefully you saw that you could set up your ratio just like this, the way I did on the previous slide. And the way we would solve this is we would cross multiply. So I would get 13 times the sine of 61 is equal to B times the sine of 55. I'm going to scooch it in right there. So when we cross multiply, boom, boom, boom. And if I'm solving for B, B winds up being, it looks a little messy, but it's actually okay. 13 times the sine of 61 degrees over the sine of 55 degrees. And you can throw all of that into your calculator and figure out what B is. And you get, drum roll please, approximately 13.88 for the side length B. So now I want you to pause the video again and try to solve for C. All right, we're back. So a great rule of thumb is if this is your initial starting ratio, like this is what's given to you, that 55 degrees and then the opposite side length, use that again, almost like it's our scale factor, remember from similar figures. Use that again because in case, God forbid, but in case you made a mistake in solving for side length B, like if you did sine of 61 over 13.88 and you use that as your starting ratio, you might have made a mistake, right? So you don't want to do that. So always go back and start with that first ratio. And then if you set that equal to the sine of 64 over C, you cross multiply, you solve, and you get approximately 14.26 for the side length C. And then we're now missing angle C. So shoot. All right, so let me set up my ratio again. Oh, wait, I don't have to because I know that the sum of the interior angles in a triangle add up to 180. So you know that C is going to be 64 degrees. Hopefully you felt really good about that. If you didn't, pause, rewind, go back and watch it again. All right, so now we're talking about a side-side angle situation. So we talked about angle, angle, side, but now we've got a side-side angle, and it's going to be a pain in the side-side angle. So it's going to be a pain in the side-side angle because in a side-side angle situation, I could have one triangle, I could have two triangles, or I could have zero triangles. And we have to test for that, which is annoying, but it's possible. So let's try. So I'm just going to show you how we could get two possible solutions here. So here is my set side, my other set side, so 28, and then this set angle. And see how 28, like I don't know what this angle could be or this angle. We have no idea what those angles could be. And so that side can really like hinge. I like to think about like these being connected, right? So we could hinge like this kind of along this dashed line. So I would get an angle right here. And if it's still hinging on this little guy, I would also get an angle right here. And so we've got two possibilities, really, more than that, because we've got these angles too, right? That all change. And so we've got two possibilities here for what those angles could be. And they're actually supplements of each other. So if we have two triangles in this situation, we have to test for the supplement of those angles. And you'll see what I mean in a second. All right, so here's a situation. It's side angle, and we're only going to get one triangle here. So I want you to pause the video and solve for A. All right, we're back. This one's a little bit trickier because we haven't solved for an angle measurement yet. So hopefully you set up your ratio just like this. And then if you cross multiplied here, you're going to wind up getting 5.5 times the sine of A equals 4.7 times the sine of 63. Solve, 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 solve. You wind up getting the sine of A equals 4.7 times the sine of 63 degrees divided by 5.5. And remember, in your calculator, this is when you would do the inverse sine. So you do the inverse sine of everything that's right here. And that would give you what A is. And A is, drum roll please, 49.59 degrees. Okay, so if we see that we have a side-side angle situation, we know that we could potentially have one or two or zero triangles. We haven't talked about zero yet, but here's how we test. So we know that this could potentially be an angle measurement. So also though, about that hinge, right? We also could have an angle here that is the supplement to 49.59. So what you're going to do here is find the supplement of it. So 180 minus 49.59. And so in your calculator, live, I'm doing this. So 180 minus 49.59, and we got 130 0.41. So our question here is, could A be equal to this? What do you think? Could angle A be equal to 130.41 degrees? The answer is no, because look, C is 63 degrees. So 130 plus 63, that's way more than 180 degrees. Not actually way, but you know what I mean. So that's more than 180 degrees. And so then we know that there can only be one triangle here. You're going to see in the next slide when there could be two. And then if there's only one triangle, you just keep going and you solve for the rest of the triangle. So now let's look at this other pane in the side angle. So I want you to pause the video here and I want you to solve for angle C. All right, we're back. So you solved for angle C. Hopefully this was your initial setup. And then you cross multiplied, amazing. You did the inverse sine, awesome. And you wound up getting that C was 67.15 degrees. Amazing. Now we're going to test this again. So let's test this guy and let's see what we get. So we would do 180 minus 67.15 degrees. So I'm doing it live. 180 minus 67.15 degrees is going to be 112.85. So we're saying here, could C be equal to that? And let's think about it. Well, plus 39 degrees, does this give me something that is less than 180? It does. So what that means is we have two triangles here. We've got one triangle that looks like this, 41, 28, 39, and then 67.15 degrees, right? And then we've got another triangle that looks like this. Again, 41, again, 28, again, 39. But now the top is going to be 112.85 degrees. So you would have to solve two triangles here. So annoying, but you could do it. You just have to do law of sines over and over and over again. I promise that life is not that hard, and we are in this together. But hopefully that makes sense. All right, so now let's talk about the zero triangle situation. So let's try this one. First thing you got to do is you've got to draw the figure. So you know side length A is 23, side length B is 3, and the measurement of angle B is 44. So pause the video, draw the figure first. All right, we're back. So here is what the figure looks like. Hopefully you feel good about this. Now I want you to pause the video and solve for angle A. Go. All right, we're back. So hopefully your setup looks like this. And when you went through and solved, you wound up getting this. So you get the sine, 3 times the sine of angle A is equal to 23 times the sine of 44 degrees. And so then in your calculator, you would do inverse sine of 23 times the sine of 44 degrees divided by 3. And you probably got an error. So when you get an error sign in your calculator, if you do it correctly, that means you have no triangle. And what this is saying is there's no possible way with these parameters I could draw this triangle. So like your triangle would look something like this. Here's my 44-degree angle. It looks something like that. This side length is 23, and this side length is 3. So there's no way, no matter how I hinge this little guy, there's no way that I could like hinge that to have it reach that 23 side. Does that make sense? So it would look something like this. I mean, this is like a super crude drawing, but it would look something like that. That's what the no triangle means. All right, one last thing I wanted to make sure that I presented to you, and then you are home free, is you also can find the area using sine, the area of a triangle, which is kind of cool. Now notice this has to be a side angle side situation. So I've got a side, an angle, and a side. And all you have to do here is plug this information into this into this equation. We're going to work on the proof in class where this comes from, but essentially the area of this whole thing is going to be 1/2 the two sides, 16 times 42, times the sine of that included angle. So in this case, it's 68 degrees. You kind of got to punch some numbers here in your calculator and you get the answer out. Whew, okay, that was a lot of info, but I think you're going to get it. We will do a lot in class together. Don't worry. And think of, again, you've got so many tools here in order to solve missing sides and missing angles of a triangle. And now you can do it for a triangle that's not right, which is amazing. All right, so good luck on the homework. I will see you soon. Thanks.